So next we have Morgan Roberts. Can uranium exposure contribute to skin cancer? And the advisor is Diane Stearns.
The link between skin cancer and sun exposure has long been established. The radioactivity of uranium is also well known to cause cancers. However, there's a less radioactive form of uranium that must be considered. Depleted uranium comes from making enriched uranium, which we use for energy. Depleted uranium was used for tank arm and ammunition in the Gulf War and is still being used in the military today. People exposed include miners, processors, and military personnel. Although considered a slightly toxic metal, it is not yet considered a cancer-causing chemical or carcinogen. This research project focuses on the combined exposure of sunlight and depleted uranium on the skin. Combined exposure studies are more realistic than single exposure studies because in our lives, we're most likely being exposed to more than one thing at a time. My research group looks at whether or not sunlight can activate uranium, causing it to have different types of DNA damage than would normally be expected for each exposure alone. Depleted uranium by itself is not known to cause skin cancer, but the question that we want to answer is, can sunlight activate uranium, giving it the potential to do so? When you are exposed to two separate things, the result is analogous to 2 + 2 = 4. We've seen results that resemble 2 + 2 = 10 when cells are exposed to depleted uranium and sunlight. When a cell experiences damage to its DNA, it must be repaired. Much like the bones in our body are repaired, DNA is repaired in cells. If not, the cell will die. Sometimes, the cell can repair this damage incorrectly, and the cell can live on and propagate this damage to future cells. Unfortunately, we cannot see inside the cell to see what is going on, so we must rely on biochemical methods to gather our information. So, the purpose of my project is to look further into DNA damage and cellular death by looking at how the cell recognizes this damage and then decides how to act. I tag proteins inside the cell with a reflective cell marker that acts like a mirror. I then hit the cell with light. The light that comes back off the cell marker gives me an idea of how the cell is responding to damage. My results show that when cells are exposed to depleted uranium and sunlight, the cellular death is greater than with each exposure alone. However, not all the cells are dying. This supports the idea of sustained cellular damage, which could lead to cancer down the road. A lot of lab research uses unrealistically high doses to induce a result. In contrast, my research uses realistic doses, such as the dose of sunlight used is equivalent to 1 hour spent outside on a typical Flagstaff day in June. The dose of uranium closely resembles levels of uranium found in contaminated water sites in Arizona. My research is important because skin cancer rates in the Southwest are increasing, a place where people might be exposed to high levels of uranium and sunlight. Thank you.